Let's solve some more questions from circles and tangents. In the first question, it's given that O is the center of the circle, PQ is a tangent to the circle at T, chord AB produced meets the tangent at P. Then some lengths are given, AB is 9 centimeter, BP is 16 centimeter, and some angles are given. Angle PTB is 50 degree, OBA is 45 degree. Then we have to find the length of PT. So let's focus on that first. We know that from tangents that if there is a chord and a tangent intersecting externally, then the product of segments of the chord is equal to the square of the length of the tangent. So the chord AB, when it is produced, it's meeting the tangent PT outside the circle at point P. PT is my tangent. So I will say that the product of the lengths of the segments of the chord. So in this situation, the segments of chord AB will be AP and BP. These are the two segments. So I will say that AP into BP equal to the square of the tangent. So here it is PT square. And reason I will write that chord and tangent intersecting externally. Okay, then let's just plug in the measurements that we know. The length of AP will be 9 plus 16. The entire length of AP will be 9 plus 16, which is 25. And BP is given as 16, so that is PT square. If I take the square root, I will get PT equal to square root of 25 into 16, which is root of 25 into root of 16. Root of 25 is 5, root of 16 is 4, 5 into 4 is 20. So 20 centimeter is the length of the tangent PT. Okay, done. Then there are three missing angles. Let's find out. First is angle BAT. BAT. So angle BAT is the angle in the alternate segment. If I look at my tangent TP and chord TB. So the angle between the tangent and the chord here is angle BTP or PTB, which is your 50 degree angle. Therefore your BAT angle will also be 50 degree. So I will say that angle BAT is actually equal to angle PTB, which is 50 degree. And the reason you will write angle in alternate segment. Okay. Then let's look at what is angle BOT. Now, if you look at angle BOT, it's the angle subtended by the arc BT at the center, and BAT is the angle subtended by the same arc at the remaining part of the circle. So, angle BOT will be 2 times of angle BAT, which is 2 times of 50, which is 100 degree. So you know what reasoning to write. Angle subtended at center is twice the angle at remaining part of the circle. Okay. Then for the last part, angle ABT. ABT. Okay. So for that angle ABT, let's look at finding angle OBT first. Then ABT will be this 45 degree plus OBT. Okay. Now for OBT, you can see that we have a triangle OBT where OB and OT are the radius of the circle. So OBT is an isosceles triangle, base angles are equal. Okay, and then I have OT as my radius, TP as my tangent. You know that radius and tangent are perpendicular, so angle OTP is 90 degree. Radius and tangent are perpendicular. Therefore, if I look at angle OTB, it will be the full angle OTP 90 minus this 50 degree. So it will give me 40 degrees. So I have OTB 40 degree Therefore, angle OBT is also 40 degree. Base angles of isosceles triangle. So you need to write all that reasoning, that radius OT and OB are equal, then angle uh, OTB and OBT are base angles of isosceles triangle, and then the last thing is to find angle ABT. So angle ABT will be 45 degree plus 40 degree, which is 85 degree. Moving ahead. In this question, O is the center of the circle. Tangent PT meets the diameter RQ produced at P. First, we need to prove that triangle PQT is similar to triangle PTR. Okay, let's focus on that. In the triangle PQT and PTR, we need to look at which angles are equal. So first thing is angle P is common. For both the triangles, angle P is common. And then I can look at tangent PT and chord TQ have angle PTQ in between. So this angle PTQ is equal to angle in the alternate segment. So angle in the alternate segment is angle TRQ. So that reasoning you can write that angle PTQ is equal to angle in the alternate segment, which is angle TRQ. Okay, so we have two pairs of angles which are equal. Then if I compare triangle PQT and PTQ, I can say triangle PQT must be equal to triangle PTR, because angle P is common in both the triangles, and from PQT I have angle T. This angle T is equal to angle TRQ. TRQ, which is angle R in the second triangle. So since I have two angles equal, two corresponding angles equal, the triangles are similar because of AA similarity criteria. Okay, so the first part is done. Then for the next part, they are asking the length of PQ. Given PT is 6 centimeter, QR is 9 centimeters. So PQ length is not known. Let's say that PQ is X. Now I have QR as the diameter. Diameter is also a chord. So if I extend the chord outside the circle, it meets the tangent PT at external point P. So here we can apply the theorem that the product of lengths of segments of a chord is equal to square of the length of the tangent. So segments of the chord will be PQ and PR. So product PQ and PR is equal to PT square, and you can write the reasoning. Then PQ is X and PR length is X plus 9. That is equal to 6 square. So X square plus 9X, 6 square is 36. If I bring to the left side, that is minus 36 equal to 0. Then this is a quadratic equation. You can either factorize or use the formula. If I am factorizing, I can split the middle term 9x as plus 12x minus 3x. So then x into x plus 12 minus 3 into x plus 12 equals to 0. So x plus 12 multiplied by x minus 3 equals to 0. So I can say x equal to minus 12 or x equal to 3. But x equal to minus 12 is not possible because x is length is positive. So I will say x is 3. So therefore the length of PQ is 3 centimeter. Alright. Moving ahead to the next question. In the figure given below, diameter AB and chord CD of the circle meet externally at point P. And if PT is a tangent to the circle at T and some other measurements are given, we need to find the length of AB and the length of PT. Okay, so let's first look at how to find length of AB. So for that we can use the theorem which talks about two chords intersecting externally. So here chord AB and CD of the circle are intersecting externally at point P. Then the theorem is that the product of the length of the segments of the two chords are equal. So here if I look at the product of the length of segments of AB, I have segment is AP into BP. This product must be equal to the product of lengths of chord CD, the segments of chord CD, which are in this situation CP into DP. Let's say that the length of AB is X, and it is given that CD is 7.8, PD is 5, and PB is 4. Okay, so then AP length will be X plus 4 into BP length is 4, which is equal to CP length, which will be 7.8 plus 5, which is 12.8 into DP, which is 5. So X plus 4 into 4 is 12.8 into 5, which is 64. Divide both sides by 4. X plus 4 will be 16. So X will be equal to 12. Therefore, the length of AB is 12 centimeter. That's the first part. Then for the second part, we need to find length of tangent PT. So for that, I can consider either chord AB or chord CD. Any one will be fine, because either one of these chords, they are intersecting the tangent PT outside the circle. So then we have a theorem, we can apply that. Let's consider the chord AB. So AB, the product of segments of AB are AP into BP. That will be equal to the square of the length of the tangent. So here AP length is 12 plus 4, 16. BP length is 4, that is PT square. So if I take square root, root of 16 is 4, root of 4 is 2. So I'll get 8 centimeter as length of PT. Moving ahead, the last question. In this figure, the quadrilateral PQRS is given, and the sides of the quadrilateral is touching the circle at points A, B, C, and D. Then some lengths are given. We need to find the length of PQ. So we need to find the length of PQ. Okay, so let's use the theorem that the length of a tangent from an external point to the circle are equal. So I can draw two tangents from an exterior point to a circle, and those two tangent lengths will be equal. So I can say that PA will be equal to PD. PA and PD are tangents from exterior point P. So PA will be 5 centimeter. Two tangents from external point to circle are equal. That's the reason. And similarly, I have the tangents CR and BR. So they will be equal. So I will say that BR equal to CR equal to 4 centimeter. Now, entire length of QR is given as 7 centimeter. Therefore, QB I can say is 7 minus 4, which is 3 centimeter. QB is 3 centimeter. Now QB is same as QA. QA equal to QB equal to 3 centimeter. Therefore, the length of PQ will be 5 plus 3, which is 8 centimeter.